All right, Algebra 2. In today's lesson, we're going to be looking at functions and how to state the domain and the range of a function. All right, so a function can be written in different ways. One could be written as ordered pairs, a set of ordered pairs, x comma y. We could also look at it as a graph. We could also look at it as a mapping or an equation. So if we're given a set of ordered pairs, x comma y, we're looking at all the x values, and we just want to make sure that the x values are not repeating. So for example, if we have a set of ordered pairs that are given to us as, let's say, 0, 2, comma, 0, 3, comma, 1, 5. All right, if we look at all the x values here, since the x values, we have a pair where the x values are repeating, this is not a function. All right, but if we were given a set and none of the x values are repeating, then we could say it is a function. All right, now if they give it a function as a graph, we're looking at will a vertical line cross two or more points at the same time for each vertical line that we draw. All right, and if you can draw a vertical line and it intersects two or more points at any time for any vertical line, then we say that is not a function. And then a mapping is a way to show ordered pairs where you have numbers on the left side of like a circle or an ellipse, and then numbers on the right side, and there's arrows pointing from numbers on the left side to the right side. And as long as you don't have two arrows coming off of a left number, so a number on the left side, there's not two arrows coming off of it, pointing to two different numbers on the right, then it's a function. All right, so let's look at some examples here of functions. So if we look at this first one with these four ordered pair points, we can see that if we were to list out the ordered pairs, now you can list out ordered pairs with x comma y. You could also list them out as a table. All right, so if we were to kind of look at this as a table, these 4 points, and if we were to list out the points, we can see that we have -2, +1, 0, 2, 1, -1, and then 3, 0. And if we look at all the x values, none of the x values are repeating, and so this is a function. Another way we can see it is by doing the vertical line test because it's a graph. So if I were to take a vertical line and I draw it anywhere on this graph, I can't intersect 2 points at the same time. So any vertical line that's drawn, I'll never be able to intersect 2 points at once. So this is another way to see it as a function. If we go over to this W graph, again, if I draw a vertical line, every time I draw a vertical line, I'm only going to intersect 1 point, okay? 1 point each time. Same with the other graph down here. These end lines are not going vertical, they are going out at an angle. So every vertical line I draw is only intersecting 1 time. Okay, now on this mapping with these two ovals or ellipses, you can see arrows coming off of it. And so you can write these as ordered pairs. All right, so if we were to list out the ordered pairs, we can see that -3 is being pointed to -1. All right, so the numbers on the left side act as the x values, and the numbers on the right side act as the y values. All right, another ordered pair, we can see -1, -2. 1, -1. And then, oops, that's +1, -1. And then 2, 0. Okay. And if you look at all the x values, we can see that none of the x values are repeated. And so this is a function. All right, now let's look at some examples of things that are not functions. All right, so in the first one with these 5 points, we can see if I draw a vertical line, I can pick up 2 points with one vertical line right there. And as soon as I do that, I can see that this is not a function. Again, if I were to list out these ordered pairs like I did on the other side, you could see it even with an XY table. So I have -2, 0. I have -2, -3. I have -1, 1. 0, -2. And then 1, 1. And right here, because the x values are repeating, it's not a function. All right, if we look at some of these other graphs, this circle right here, here's a vertical line drawn, and I can pick up 2 points at once, one vertical line on this graph, so this is not a function. This vertical line right here, I draw a vertical line through a vertical line, I intersect in an infinite number of points, so this is not a function. For this mapping, I can see right here, this is the point that it fails, that it's not a function, because if you list out the ordered pairs, that's 1, -1, and then also 1, 0. All right, and now you can see that the x values have repeated. So the y values can repeat, it's the x values we don't want to repeat. All right, so that's how you can kind of determine if you have a function or not. Now, if we have a function, we have what's called function notation. You're used to equations that say like y equals something. So what we're going to do is replace y with f of x. And so that's what this notation is. It says f of x, not f times x. So instead of having like y equals 3x, we could write it as a function, and that's f of x equals 3x. All right, and it means the same thing as y equals 3x. So if you're given an equation and you kind of get stuck with what does f of x mean, you can just replace f of x with y and write it that way instead. All right, we can evaluate functions if they give us a graph, a table, equations, mapping. And so here they want us to evaluate a function, and they give us a graph for this first one. So what f of x means is the number that's inside the parentheses is the x value, right? So this is our x value right here. And what we're trying to do is find the y value that corresponds with that x value. So if we go to our graph, we want to find out what is f of -2. So what we're going to do is go to -2 on the x-axis. Okay, so you just have to go to the left. And then, so here's -2 right here. And so we're trying to find the point that uses -2 for x. And so what we're going to do is, if you draw out like a vertical line, you'll find out where the intersection point is. So it's right here. And so what we want is the y value that corresponds when x is -2. So this ordered pair right here is the point -2, 1, 2, 3. So when x is -2, y is +3. All right, so again, they're giving you x, they want the y. All right, so let's do f of 0. So again, they're giving you what x is, okay, and they want you to find the y value. All right, so we go to 0 on the x, and here we'll draw a vertical line to find the intersection point, which is right here. So this ordered pair right here is 0, 1, 2, 3, 4, 5. So when x is 0, we say y is 5. So again, we're trying to find the y values. Okay. F of 2. So here we'll go to +2 on the x. Okay, so here's +2, and we need to find the point of intersection. So there it is right there. So this point right here is 2, 2. So when x is 2, we say y is 2. Okay. So again, you're just trying to find the point on the graph that uses the x value that's given, and you're trying to just keep the y value. All right, now if they give it to you as an xy table, it's a little bit easier. So again, they're giving you what x is, and you have to find y. So when x is -2, we can see that y is -2 also. When x is 0, we can see y is 0. And when x is 2, y is 4. Now when they give it to us an equation, again, the number inside the parentheses is your x. So you're going to substitute that x value in to the right side and evaluate it using ordered operations. So if I want to find f of negative 2, I'm substituting negative 2 in for x. Now I use the order of operations to simplify the right side. So this is negative 4 minus 10. So f of negative 2 equals negative 14. Okay. So when x is negative 2, the y value would be negative 14. All right, so if we try 0, f of 0, again, we're going to plug 0 in for x. Again, order of operations. So 2 times 0 is 0, minus 10 is negative 10. And then plugging 2 in, 2 times 2 is 4, 4 minus 10 is negative 6. Okay, again, the number in the parentheses is your x value, and the number on the right side of the equal sign is the y value. All right, now when they give us a graph, here they want us first to determine if we have a function or not. So if we have a function, we're going to do what's the vertical line test, so what we learned at the very beginning. So if you can draw a vertical line and intersects the graph more than once, anywhere on the graph, then it's not a function. Then we'll also talk about the domain and the range. All right. So let's first determine if we have a function or not. All right, so on this first graph, number 4, if I take a vertical line and I intersect anywhere on this graph, okay, any vertical line will only intersect in one place. So yes, this is a function. Now to determine the domain, what we're going to do is look at all the vertical lines that actually intersect this graph, and we always have to move from left to right. So the first thing you kind of want to look at is if you were to draw a vertical line at the furthest left that you can go. So we'll just draw a vertical line over here. And this is where negative infinity is. So the question is, will your graph ever intersect that vertical line where negative infinity is? Well, on this graph, no, it won't. So what we do is we start to slide this vertical line across to the right, and we want to find out when does it first intersect the graph. Well, the first place that it intersects the graph is right here. Okay, that's the first place. And we want the x value of where it intersects. Okay, so the x value that it intersects is negative 1, 2, 3, 4 at negative 4. Okay, and because it's a closed circle, we have to use a bracket. Okay, so we're using interval notation. So what we're going to do is take that vertical line and continue to slide across to the right and find out, does it continue to hit everywhere on the graph? Well, yeah, it continues to hit everywhere, okay, but on this graph, there's one place where it stops and it doesn't hit anymore, okay? And so the last place that it hits, kind of erase all this other stuff so you can kind of see it, is right here. This is the last vertical line that intersects the graph, and that's when x is positive 2. Okay, and because it's a closed circle, we use a bracket. Now I can see that if I were to take a vertical line and I continue to slide it across to the right, okay, if I put one over here, okay, so let's say that's 10, that vertical line 10 will not intersect the graph. Okay, so these are the only vertical lines that intersect this graph from negative 4 to positive 2. So then when we do range, we think from bottom to top. What horizontal lines intersect? Okay, so again, we start at the very bottom. Okay, and we'll come way down here. And this is where negative infinity is on the y's. And I can see that this horizontal line will not intersect the graph. So now I start to slide up and move it up, find out when does it first hit. Well, I can see that it's first going to hit this graph right here. And I want the y value. Well, the y value would be negative 2. And because it's a closed circle, I use a bracket. And then I'm going to start to slide it up. And I can see every time I draw a horizontal line, it intersects the graph. Okay, and then there is a last point that it's going to hit is right here. And I want the y value of where it stops. So it's 1, 2, 3, 4. And because of a closed circle, we use a bracket. So the range, we say, is from negative 2 to positive 4. And you can see that if you were to draw a horizontal line way up here, like positive infinity, that line will not intersect the graph ever. Okay, so let's go ahead and do number 5. So first determine if it's a function, and we can see that every vertical line that's drawn only intersects one time. So yes, this is a function. All right, now we want to do the domain. So we start at the farthest left and draw a vertical line, and you have to ask yourself, will that graph and that line that's drawn ever intersect each other? Well, no, they won't. So we start to slide this vertical line across to the right, find out when does it first hit. So again, we want the x value of where it first hits. And so this is it right here. And so the x value is negative 1, 2, 3, 4, 5, 6, 7. When x is negative 7, and we use a bracket because it's a closed circle. And we slide that vertical line all the way across, and it continues to hit everywhere, all the way to this point right here. That's where it stops. And so we need the x value of where it stops. And so it looks like 1, 2, 3, 4, 5. And because of the open circle now, we use parentheses. All right, so now let's do the range. So range, we work bottom to top. We're down here, draw a horizontal line at the bottom. Again, this is where negative infinity is for y. It doesn't hit the graph, so we start to slide it up, and we want to find out when does it first hit. And it's going to first hit right here when y is negative 1, 2, 3. So when y is negative 3, start there. And because of the closed circle, we use a bracket. Okay, and then we start to slide it up, and it's going to stop hitting our graph right here. And that's at positive 1, when y is positive 1. And because of the open circle, we're going to use a parentheses. All right, number 6, okay, to determine if it's a function. So every vertical line that's drawn only intersects one time, every time. So yes, this is a function. Now let's determine the domain. Okay, so again, if I draw a vertical line to the furthest left at negative infinity, it's not going to intersect the graph. So I slide it across, find out when does it first hit. So it first hits right here, and we want the x value. So that would be negative 1, 2, 3. And because of the open circle, we use a parentheses. Right, and then we continue to slide it across, and it stops hitting our graph right here. And that's at 1, 2, 3, 4. And because of the open circle, again, parentheses. Okay, now we'll do the range. So we'll work bottom to top. That horizontal line will not intersect, so we slide it up, find out when does it first hit. It first hits right here, and y is 0. And because it's a closed circle there, it's a bracket. And we slide it up. It's going to stop hitting our graph right here. So it's at 1, 2, 3, 4, 5, when y is 5. We have open circles, so it's parentheses. All right, number 7. Determine if this is a function. So if I draw a vertical line through this circle, I can see right here it fails because it hits in 2 places, and no, this is not a function. Now I can still state the domain and range even if it's not a function. Okay, again, I start at the furthest left and draw a vertical line. I can see that that vertical line will never intersect the graph, so I start to slide it across and find out when does it first hit. Well, I can see that it's first going to hit right here, and I want the x value. So that would be at negative 1, 2, 3, 4. Negative 4. And because it's a solid line, it means it's closed, so I use a bracket. And then I continue to slide it across, and it'll continue to hit all the way to right here. And that x value is 1, 2, 3, positive 4. Again, I use a bracket. All right, now I want to find the range. So I work from bottom to top. I can see this horizontal line will never intersect. So I slide it up, find out when does it first hit. And it's first going to hit right here. We want the y value, and that's at negative 1, 2, 3, 4. And because it's a solid circle line, we use bracket. Okay, and then we slide it up, find out when does it stop hitting our graph. This is where it's going to stop hitting. And so that's at 1, 2, 3, positive 4. again, we'll use a bracket. All right, number 8, determine if this is a function. And I can see right here it fails, right here it fails, right here it fails. So no, this is not a function. Okay, I just have to find one vertical line that intersects the graph more than once. Okay, and then it would not be a function. All right, so now I want to determine the domain. So again, start at the farthest left. Okay, I can see that vertical line will never intersect that graph. So I start to slide it across. Find out when does it first hit. You should be able to see that it's first going to hit right here. And again, I want the x value, so that would be at 0. And it's a solid line. It's not dotted, so that means it's a bracket. And I continue to slide it across, and it continues to hit everywhere. Okay, and then the furthest right I can go, this is considered positive infinity. And the graph will intersect that line at positive infinity because of the arrows. It continues to go forever. And so they do hit at some point. So we say to positive infinity. And we always use parentheses on infinity or negative infinity. All right, so now we do the range. So again, we start from the bottom. So horizontal line down here at the bottom. So the question is, will that horizontal line intersect the graph ever? Well, yes, it will, because of the arrows. If we extend this graph out, at some point, it's just going to continue forever, and we continue our horizontal line, they will intersect at some point. So that means it first hits at negative infinity. Now, as we slide it up, it's going to continue to hit everywhere. Okay, continues to hit. Okay, now if I'm up here at positive infinity and I extend this graph far enough, it will continue forever, and they do intersect each other. So this is going to be positive infinity is where it stops. So it's going to go from negative infinity to positive infinity for the range. So always look for arrows, because you have to understand that it goes forever in that same direction. All right, and then the last one, number 9. Function. Yes, this is a function because every vertical line that's drawn only intersects one time. Okay, now let's do the domain. And again, we start at the furthest left and ask ourselves, will that vertical line ever intersect this graph? Oh, no, it won't. So I start to slide it across, find out when does it first hit. Well, it's first going to hit right here, and that's when x is 0. And because of the open circle, we use our parentheses. Right, and we want to find out when does it stop hitting. While we slide this vertical line across, it continues to hit. And because of that arrow on the right side, if I draw a vertical line where positive infinity is, and I extend this graph out far enough, they will hit eventually. And so this is going to basically stop at positive infinity. All right, now the range. Okay, horizontal line down here at negative infinity. So this vertical, or the horizontal line, will not intersect the graph ever. So I start to slide it up, and I want to find out when does it first hit. Well, it's not going to hit. It's not hitting. It's not hitting, but it will hit as soon as I draw this one right here, and that's at 1, 2, 3, 4. Right, and then as soon as I pass 4. Okay, it doesn't hit anymore. So there's only one number part of the range, and that's at 4. And then we use a bracket on this when there's only one number. Okay, because 4 is the only number that actually works. All right, and so that's how you do domain and range, and then determine if it's a function or not.